Welcome once more, grade 12s. I hope your studies are going very well. I hope you are all good and you are still pushing in terms of preparation for your final examination. And yeah, on this lesson, I'll be looking at another very important section of differential calculus. It's called sketching of cubic graphs. So if you recall on the previous lessons, and I will also plead if you are watching these videos for the first time, if this is the first video that you are catching, I will encourage you to go back and review the videos and lessons that I've already covered in order for you to get an understanding of what sketching of cubic graphs is all about. So what we've been doing from lesson 1, we've been looking at key concepts of differential calculus. We started by looking at functional notation, then we moved to average gradient, then we looked at limits, we looked at first principle, derivatives, rules of differentiation, we looked at equation of a tangent line, and we also did some tutorial problems that are focusing on first principle and derivatives to enhance our problem solving skills in terms of the application of these rules. And then on the previous lesson we also looked at polynomials, which is a section that is covering remainder and factor theorems. And as I already mentioned on the previous video, the topic of polynomials, it doesn't necessarily mean, or how can I put this? In some of the books, this chapter or this subtopic of polynomials, it's a chapter on its own. It's not a subtopic of differential calculus. But it doesn't really matter if it's the first chapter of the syllabus, it's the last chapter of the syllabus, it's a subtopic of another topic. What is really important is that you as a matriculant, you need to know what polynomials are all about and where we apply remainder and factor theorems. Okay, so yeah, if you are joining for the first time, I will plead with you to review and revise those topics that we've already covered. Coming back to today's lesson, sketching of cubic graphs. Now let me take you back to previous grades and a very important topic or chapter that we've covered also this year in metric, which is functions and graphs. So I will believe now you know the different types of graphs that we are having. We've got straight line, we've got parabola or quadratic graphs, we've got hyperbolic graphs, we've got exponential graphs. So now we're gonna add another exciting and a bit complicated graph. I'm saying a bit complicated in a sense that it's quite demanding in terms of what you need to achieve first before you can start sketching those particular graphs. But having said all those things, I will take you through all the steps and the tips so that you understand the key parameters that you need to look at before you can even do sketching of cubic graphs. Okay, so it's it's not a very complicated subtopic, but I can guarantee you in your examination you're gonna get a question that requires you to sketch or interpret cubic graphs. Talking about cubic graphs, that will be the next lesson on the next video. Okay, so yeah, I think by now we've already got an idea of what we've been doing and what we've done so far. Let's get to business. Okay, so let me get a pen. So we will be sketching off graphs. So the key concept there is sketching. We are not plotting, we are sketching. We are looking at a rough sketch of what the graph looks like. But basically when we say sketch, we don't want you to draw it to scale, but the shape and the parameters of that particular graph must make sense. Okay, so what do we mean by cubic graphs? So cubic graphs will be looking at graphs that are in the form of y is equals to ax cubed plus bx squared plus cx plus d. Okay, so this graph will be in a form ax cubed plus bx squared plus cx plus d. You will recall that with parabolic graphs, they were taking a form y is equals to ax squared plus bx plus c. So this was a quadratic, and then this one it's the what do you call it? It's the cubic graphs. Okay, now few things that you need to take into consideration first before you can even sketch the cubic graphs. Just like any other graphs that we've covered before, it needs to have a certain characteristics. We need to determine certain parameters. Okay, now the first thing that we need to look at before we can even look and attempt at the problem, we need to look at the shape. Okay, now maybe I'll just excuse the let me cancel this. Just want to get a nice so that when I refer to cubic quadratic graphs, I can only focus on this block. You will recall that parabolic graphs can either take the shape like this or like that, depending on the value of a. Okay, but when it comes to cubic graphs, we've got, I'll show you 4 options. The first option that we're gonna get is that, the main thing about the cubic graphs is that they got what we call turning points, but yeah, we'll get to that later. So in terms of the shape, if a is greater than 0, meaning it's positive, what's going to happen is that your graph will look like this. Okay, now if you compare the two here, you'll see that you've got one turn there and the second turn there, and again we can have a situation where the graph looks like this. It's about to turn, but instead of going down, it continues to go up. Okay, with a turning point there. Okay, and if a is less than 0, the graph will go down first, go up, and go down again. So with 2 turning points there. Similarly, you can have a situation where it goes like this and then it goes back and continues to go down with a turning point like this. The most important thing that you need to look at there, it's this point here. This is where the gradient is equals to 0. So this is what you call also the turning point. So here we know that the gradient is equals to 0. The gradient is equals to 0. The gradient is equals to 0. If you look at the first scenario there, the gradient increases, positive, 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 then it gets to 0, then it decreases, then goes to negative, 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 then it gets to 0, then it increases again, positive, positive, positive. When you look at this one, the gradient increases, positive, 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 then it gets to 0. Instead of decreasing, it continues to increase again, positive, positive, positive. If you look at the second scenario where a is less than 0, the graph, so we've got m here is equals to 0, m here is equals to 0, m here is equals to 0. Okay, so the graph here will go negative, 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 and it gets to 0, then positive, 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 and you can see it's going, when it's negative it's going down, when it's positive it's going up, then it gets to 0, and then it must go down with a negative, 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 and so on. Similarly here, it goes from negative, 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 then when it gets here, it becomes 0. Instead of going positive, it continues to go negative, negative. Okay, so that is what you call, that is the first parameter that we need to look at when sketching of cubic graphs. But I've realized that I actually mentioned another important parameter that we need to look at. So I will just mention here and turning points. Okay, so number 1 and number 2 here, we look at the shape, which is that, and the turning points. By the turning points, I've already mentioned, so we are looking at this. This is the turning point. These are what we call turning points. These are what we call turning points, where the graph changes from being positive to negative, or from being negative to being positive. Okay, so number 2, I would say we need to look at turning points, or what we call stationary points. So turning point and stationary points. One important thing that is very important about turning point and stationary point is that the gradient, which is m, or the gradient, or f prime of x, or g prime of x, doesn't really matter which notation you're using, it will depend on the question, is equals to 0. That is very important. So after deriving this equation, you equate the gradient. You equate the gradient to 0, then you proceed. Okay. Then you will get the x value of the turning point. Okay. Let me repeat that. For you to determine the gradients, for you to determine the turning points, the stationary points, you first differentiate your cubic function and you equate it to 0. Then you solve for x. So you do this, solve for x, then after solving for x, substitute the value of x in what? In the original equation. In the original equation. And by original, I'm referring to what? To the cubic function or cubic graphs that is given to you. Okay? Now let's look at another one. We're looking at intercepts. So this one is what you've already know. So in terms of the y-intercept, that is very important. We know that for y-intercept, what is happening? X is equals to 0. Okay, so if you look at y is equals to ax cubed plus bx plus d, if you put everything at 0, so this will be 0, 0, 0, it will be d. Okay, and then the coordinates there, because we'll be looking at coordinates, the coordinates there will be 0 and d. Okay, if you look at the x-intercept, this is very important. If you look at the x-intercept, we know what we do. We put y is equals to 0. So from the original function, you will have y is equals to ax cubed plus bx plus cx plus d. Then we'll have 0 is equals to ax cubed plus bx plus cx plus d. Now, very important here, the question is, how are you going to solve, are you going to factorize this cubic? This is why it was very important for us to look at in the previous session, the previous lesson, to look at remainder theorem, and factor theorems. So we'll use the concepts that we've learned before to determine this by using the three methods, which are, I hope we are screaming there behind your phone or your laptop or whatever device that you're using, that is going to be synthetic, long division, and inspection. Okay, and we will now look at the fourth one, which is called the first parameter that we need when sketching of cubic graphs is what we call the point of inflection, or I can also mention and say it's when we look at concavity. Okay, so POI, point of inflection. So what is this point of inflection? Point of inflection is where the graph changes from being concave down to concave up, or vice versa. Now you may ask yourself, so you see your graph is going up, then it gets to a maximum turning point, then it goes down, and then here is where your graph changes concavity. So it was from a concave down, now it's going from concave up. So this is the point that we'll be looking at. Okay, if you look at this type of a graph, your graph was going down, down, then it gets to a turning point, then it goes up. But here, this point here is the point of inflection, where the graph changes concavity from a concave up to a concave down. Here it goes from a concave down to a concave up. Okay, when you look at our two other scenarios, your m is equals to 0, where your gradient is equals to 0. Also here, your n double prime is equals to 0. So this point is your turning point, at the same time is a point of inflection. Okay, so that is something that you need to look at. Okay, I will do an example in a couple of seconds so that you can summarize everything nicely. Here I was just giving you a snapshot of all the parameters, or the basic parameters that you need to do, or it's the steps that you need to follow in order for you to sketch a graph. Remember, you will only be given an equation in the form ax cubed plus bx squared plus cx plus d, and you'll be asked to sketch, and interpret the graph. Okay, before I go through an example, I just want us to quickly revise what I did, or just a quick run around the steps. The first thing that you need to do, you need to look at the shape. So the first thing is look at the shape. If your a is greater than 0, you've got two options there. And then if your a is less than 0, you've got two options there. Similarly on this, I can also explain what are turning points and stationary points, which is the second thing that you need to determine. How do you determine that? You take your cubic function, which is your you differentiate, you determine your gradient, which is f prime x or g of x or g prime x or h prime x, depending on the question, and then you equate that to 0. After equating that to 0, you solve for x. Then after solving for x, remember now you will be determining the turning points. So you'll be looking for coordinates. So after getting the x value, you substitute those x values in the original equation for you to get the corresponding y values. Okay. When it comes to the intercepts, if you look at this graph, it goes up, down, up, down. It will have three turning points, 3x turning points. Okay. So if you're determining the x turning points, so I've already mentioned this. Now I'm here, then I'm specifying your x-intercept. It will have 3 x-intercepts, and you know, for you to determine the x-intercept, you put y is equals to 0, and then what do? You then determine, or you use the concept of remainder and factor theorems as per the lesson or the tutorial video that I did previously. If you did not get a chance to go through it, I will advise you to watch the video so that you can understand. In terms of the remainder and factor theorems, for you to determine the x-intercepts, what do? You will use the 3 methods that are available. See here, I forgot to mention them. Number 1, you can use synthetic. Number 2, or you can use, let me highlight this, you can use long division, or you can choose to use inspection. like I mentioned also previously, that it doesn't matter which one you use, but what is important that you'll be forced to use one of the three. You decide which one you want to use. I've explained which one is easy, which one is more challenging and complex. It's up to you which one you're gonna use. And also you must bear in mind that you need to use the one that is gonna be very fast for you, because now remember here we are only determining the x-intercepts. After getting the x-intercepts, you need to get the corresponding y values, because what is our aim? Our aim is to get the coordinates. So after getting the x values, you do what? You substitute the x values to the original graph for you to get the corresponding y value. So that's why it's very important to choose a method that you are confident about, and it's going to be easy for you to get the answers very quickly. Okay, the fourth one, okay, sorry, in terms of the y-intercept, you put x is equals to 0, then your y-intercept will be the same as the value of d, and then your coordinates will be 0 and d. Okay, and then lastly, in terms of the point of inflection, or which is the concavity, I see here I forgot to mention. What do we do here? I showed you guys where the point is. What is very important about this one is that your f prime x is equals to 0. So it's going to be similarly as what you did on turning point and stationary points. So the answer that you're going to get after differentiating first time, you're going to use it to differentiate for the second time. Then you equate that f double prime x to 0. You solve for x. After solving for x, you take that value of x, you substitute it to the original equation for you to get the corresponding y value. Then you can be able to have the coordinates of the point of inflection, which is where the graph changes concavity from either being concave down to concave up, or vice versa. Okay, so that is a snapshot, a summary of the parameters, the characteristics of a cubic graph. We will now look at an example. Okay, let's look at an example where we'll be asked to sketch a cubic graph, and the question reads as follows. Given f of x is equals to minus x cubed plus 10x squared minus 17x minus 28, sketch the graph of f and show all the intercepts and turning points. Okay, so that is a straightforward question. We just need to follow all the steps that I showed you previously in getting, or in being able to sketch this graph. There's no way that you can sketch if you don't know the turning points, if you don't know the turning, the intercepts, if you don't know the shape of the graph. So you need to determine those parameters first. So firstly, looking at the shape, I'll just write here, looking at the shape without even going through calculations, we can see that the value of a is less than 0. So the graph is either going to look like this, with two turning points. Because a is negative, the graph it's declining first, and then it's going up, then going down again. So if the gradient be negative, negative, here the gradient is 0, then here it goes positive, 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 then it becomes here at 0, then it goes negative, 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 negative. Or it can also go like that. So we've got two options: negative, 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 with m being equals to 0. So before you can even calculate the intercept, the turning point, we just know that our shape is going to be like that. Okay. Number 2, we're going to look at T, or your stationary points, turning points or stationary points. And we know with stationary points that we first need to, so we've got f of x is equals to minus x cubed plus 10x squared x minus 28. So we first need to determine the first derivative, which is going to be minus 3x squared plus 20x minus 17. If you don't know how I did this, go back to the third or fourth lesson that I did on differential calculus. Sorry, where I was looking at derivative using or rules of differentiation. Okay, from here what we know about turning point is that the f prime x is going to be 0, or we're going to equate this to 0. Therefore 0 is equals to minus 3x squared minus 17. Remember, the aim here is to get the turning point's coordinates. So I need to determine my x values, and then after getting the x values, substitute them into the original formula to get the corresponding y value. So this would be 0 is equals to, if I factorize this, I will get, okay, I can put minus 3 here. This is not a nice problem to factorize. I can put in x there. Factors of 17, 1 and 17. I'll put 17 there. I'll put a 1 there. I'll put a positive there and a negative there. Okay. Therefore, 0 is equals to 3x plus 17, or x minus 1 is equals to, x minus 1 is equals to 0. Therefore x is equals to so this must be negative. X is equals to 17 over 3. 17 over 3. Here x is equals to positive 1. So for me to determine the corresponding y value, I'm going to say what is my f of 17 over 3, which is equal to be, if you use a calculator, so you substitute this in the original where you see x, you put 17 over 3. If you don't know how to do this, go to the first lesson of this chapter where I was looking at functional notation, and then you will get to an answer here of 400 over 27. The reason why I'm not showing you all the steps is that I'm trying to save time, and I believe now you should be able to know how to solve this problem. That's why I spend most of my time going through each and every key concept, so that when you get to sketching of graphs, we don't repeat what we've already covered in the previous lessons. Okay, so x value will give me a y value of 10, so it means my turning points will be 17 over 3. Then here is going to be 400 over 27. Okay. Similarly, here, after getting x value of 1, I'm going to substitute it in the original equation. So f of 1, if I substitute there, I will get to an answer of minus 36. Like I mentioned, we've invested a lot on how to solve this problem. Now we are just applying. Okay. So x value in terms of the coordinates is 1, and the y value is minus 36. Minus 36. Okay, that is my turning point. We've got 2 turning points. Okay, now number 3, we will look at intercepts. We will look at intercepts. The first one being y-intercept. So we know with y-intercept, x is equals to 0. So your y will be equals to your d, which is equals to minus 28. So this one you can directly get from your graph. Okay. And then number 2, in terms of the x-intercept, your y is equals to 0. So here, that's where it's going to be a bit hectic and it's going to take time. So we have 0 is equals to minus x cubed plus 10x squared minus 17x minus 28. Okay. So first thing, as per the previous video of polynomials or remainder factor theorems, we need to get the factor. We need to know which value that when I substitute what is the value of x that when I substitute in this formula, I will get the answer of 0. Okay, now I will pull out the calculator to show you a trick that you can use. Okay, let me clear this so that I can take you through the steps. Let me clear. So remember, when you pull out your calculator, it will be like this. So the steps that you're going to take, say mode or setup, go to number 7. Then you punch in, it says f of x. So you punch in your f of x the way it is. If it's g of x, it doesn't matter. If it's h of x, you still assume as if it's f of x as per the calculator instruction. Then I'm going to type in the equation the way it is. So I'm going to say minus x cubed plus 10x plus 10x squared minus 17x sorry, 10x minus 28 is equals to g of x. We are not worried about g of x. I'm going to start at minus 5. It's always advisable to start from negative 5 to positive 5, and it's 5. Step 1, it's 5. Then I'm going to move to my f of x, which is the same as y. I will look for a 0. There it is. So it says f of x is 0 when x is equals to 1. Therefore, what does that mean? It means if f of negative 1 gives me 0, a remainder of 0, therefore x plus 1 is a factor. That is very important. If you don't know how I came about this conclusion, again go back to the previous lesson. Okay, so we already know now, we've determined the first factor, so we know that here is going to have x plus 1 is one of the factors, and now we don't know the other factors. And then this is where I'm going to use your inspection method. Like I said, here we've got 3 options. We could use synthetic, you can use long division. I prefer using inspection method. Okay, now I'm going to say, or the rule says, I look at this x, I need to find a term that I'm going to multiply here with, so that it gives me this term, and that a term is going to be minus x cubed, sorry, minus x squared. And then in the middle, I don't know, I'll just put kx. Then which number can I multiply with positive 1 for me to give me negative 28? That number is negative 28. Okay, so negative 28 times 1 could give me negative 28. And then from here, I'm going to look at my two brackets, bracket number 1 and bracket number 2, the small bracket and the bigger bracket. So I'm going to look at 2 terms that I can group together that will give me an x squared. So it's going to be this one and that one. Okay, going back to my green, if I multiply these two, I'm going to get minus x squared. So if I say minus x squared plus kx squared, when I equate them, they must give me 10x squared. 10x squared. Then I'm going to simplify this. I'm going to divide everything by x squared. So I'm going to divide by negative x squared, negative x squared, negative x squared. Then I will be left with 1 minus k is equals to minus 10. Therefore, k is equals to, let's see, I take k to the other side, it becomes positive. Then I take 10 to the other side, it becomes 10 parts, going to be 11. Now, I go back to my equation, so I've got 0 there is equals to x plus 1, x plus 1. I substitute my bracket, so I've got minus x squared, k is 11. So I'm back here. So y-c-k, I'm going to substitute with 11. So I'm going to have 11x minus 28. Okay. I just need to make sure that everything is right there. Now I can simplify this. I'm going to have cx plus 1. If I want to factorize this, I will get x there, forgetting that this is 0. Factors of 28. One of them must be a negative here. So I will put in a negative here. And then I will put in 4 there and a 7 there, factors, and also positive there and a negative there. Therefore x is equals to negative 1, or x is equals to 4, or x is equals to 7. You can squeeze it there. Okay, yeah, I rushed this section here because I believe this is just algebra, which I will hope you're confident enough to do. Now, if I go to calculate the corresponding y value, so I will substitute this in the original, this in the original, this in the original, then I will get the y value here. I will get the y value there. I will get the y value there. I will get the y value there as well. I hope you are screaming there again. Say, wait, what is the y value are you talking about? Because we are solving for x. So the y value is what? 0, 0, 0. It means my coordinates there is minus 1, 4, and 0. And lastly 7 and 0. Now the fourth one that I'm going to look at, I'm going to squeeze it here. It's that point of inflection, where I said we're going to differentiate your first. You're gonna determine your second derivative, and then after solving that second derivative, you equate it to 0, and then you solve for x, and then you can be able to get your point of inflection. But I don't want to calculate that one now first, because it doesn't really play any important role when it comes to sketching. It's just an additional parameter that you need to get. But for the purpose of this question, as you can see, nothing was said about the point of inflection. But after sketching this graph, I will also look at it so that you can see where and how is it being determined. Okay, so now I'm going to start sketching. So I will try to get some space. So I need to ensure that I'm not deleting important information. So I'll start removing this, erasing this. My x's are there, the y's are there. Okay, what just happened there? Sorry about that. Just get the space here in the middle now. Okay, I've got my x's there, so that I don't lose important information. I've got my shape there. I need this information here. Okay, maybe let me put y-intercept here. So remember with y-intercept, so my y-intercepts are going to be x is 0 and then your y is minus 28, so that I can erase this, have some inner space for me to draw. Okay, let's see if I can get, yeah, okay, I want this, I want the Cartesian plane. Okay, just a second. Okay, now this is not what I want. Let's look at here. Yeah, this is what I wanted. This is what I wanted. Oops, what happened? Oh, sorry. Okay. Okay, so that is my Cartesian plane. Like I said, we are just doing a rough sketch, so it doesn't have to be accurate, but it must make sense. It must have all the important points. Okay, the first thing that we're going to look at, we know that our y-intercept is minus 28, so I'll just assume that this is my one minus 28. So this is minus 28, so I know that my graph will pass here. In terms of the x-intercept, I can see that I've got -1, I've got 4 and 7. So I can say maybe -1 will be somewhere here. Then I can say maybe 4 will be somewhere there, and 7 will be somewhere there. Okay? And I can already see that, and I've already determined, sorry, that my shape is going to look like that. So I can see that this one is out because I've got 3 intercepts. So this one you can only get if you've got 1 or 2 intercepts. But the moment you've got 3 intercepts, that option is already out. So we are left with this option. Okay, so these are my intercepts, -1, 4, and 7. Now I'm going to look at my turning points. My turning point, I've got 17/3 and 400/27. So 17/3, which is the same as 17/3, 3, 3, 6, 9, 12, 14, 3, 6, 9, 12, 15. So it's going to be 16 point something or 15 point something. Sorry, no. 7 divided by 3 is 7. 17 divided by 3 is 3, 6, 9, 12, 15. So it's gonna go there 5 times and I'll leave a couple of remainders. So I just know that it's between 4 and 7. And then the y value is 400/27, which would be a positive number somewhere there. So I know that my graph must turn somewhere here. It must have a turn there. And then on the other side, my turning point is 1, so +1 is somewhere here. So here it's about 17/33, and then here it's 1 and minus 36. So I will assume that if this is -28, -36 will be somewhere here. So I know that it needs to turn again somewhere there. Now it's just a matter of joining all these points. So I'll just use a different color. It must pass there. Apologies for it not being nice, but yeah, there's not much that I can do. Then it will turn here and go and pass there. So yeah, that is your sketch, your graph. I'm very silly by not mentioning your 0 there. This is your y, this is your x. Then I need to label the important intercepts. So this is the turning point of 1 and -36, and then here for the turning point of 17/3 of 400/27, You can put this as commas. No. I'm sorry about that. It's advisable for you to leave this as fractions, but you can just punch this on your calculator to see what is 400 over 27. You'll see that it's a number that is positive up there, and 17 over 3 will also see that it falls between 4 and 17, and so on and so on. But make sure that you leave your coordinates as fractions, unless stated otherwise by the question. Okay, so I showed my intercepts there, I showed my intercepts there, and my intercepts there, so I'm good to go. Now going back to that point of inflection, and I said point of inflection is where your graph changes concavity. So I can look at it here and say, remember, the question is, what is my f prime x? My f prime x was, there it is, minus 3x squared plus 20x, sorry, minus 17. So for me to determine my point of inflection, I must find the second derivative. Then for me to get the second derivative, I'm going to get minus 6x plus 20. Then I equate this to 0. 0 is equals to minus 6x plus 20. Therefore, x is equals to, if you simplify this, we take 20 that side, 20 divided by minus 6, you get 10 divided by 3. Okay, then you substitute this in the original equation. Then your corresponding y value, you're not substituting this here, we are not substituting there, but you substitute there in the original. So your y value, the corresponding y value, you're going to get minus 287 over 27. And you will see that 10 over 3 is the same as 3.33, so 7 is there, 3.33, it's somewhere here, and negative 286 divided by 27 is the same as roughly 10 point something, negative 10. So your point of inflection will be a point somewhere there with the coordinates 10 divided by 3 and minus 286 divided by 27. And you can see basically this is so basically if you look at this, it's a point in the middle. So it's your point where your graph changes from concave up to concave down, concave down to concave up. So that's your point of inflection. But remember, it was not asked for this question. I was just showing you what it is and how to determine it. So yeah, grade 12, that's about it in terms of sketching of cubic graphs. It's an involved subtopic of differential calculus. It needs you to focus, it needs you to know all your steps, it needs you to know the important concepts of functional notation, which is why it was important for me to start these lessons on functional notation. It needs you to be able to determine your derivatives, which was one of the reasons why I did a video on derivatives, determining derivative and using rules of differentiation. It also needs you to know how to apply your remainder and factor theorems, which is a previous video that I've covered. Very, very important. It needs you to know how to sketch graphs, which is a knowledge that you've gained when you're doing functions and from previous grades. And it also needs you to know your algebra, like you can't go anywhere without algebra. Okay, and the rest, like they say, it's history. So I hope these lessons helped a lot. This is, from now on, this is no longer new, and I can say at this moment we've covered a lot in terms of differential calculus. We did a lot of concepts, and all of those concepts were integrated into the sketching of cubic graphs. There's still more that needs to be covered under this section. What is very important is that for every topic, lesson, video that I'm doing here, I'm not leaving you behind. Because if I left you behind in the first video, you need to go back so that you can follow all the things that I'm doing. I know I was a bit fast because I believe covered a lot of this in the previous videos. I went into more details. I invested a lot so that when we come here, it becomes easy for you to work around the problems. I wish I could do another an example, but due to time I cannot do that. I look forward to meeting on the next lesson or video, where we will no longer be sketching, but we will be interpreting these graphs. So we will interpret graphs of cubic, graphs of quadratic, and what is the relationship between cubic graphs and quadratic graphs. You will notice here something very important, that we started with a cubic graph. After differentiating, we ended up with a parabola. After differentiating here, we ended up with a straight line. So what is the relationship between these three graphs? That is what we're going to look at in the next lesson. Having said all that, grade 12s, I wish you all the best, and we'll meet some other time. Thank you very much and take care.